Okay, this is a brief recap of today's lecture. We had some technical difficulties and the lecture was not recorded or streamed. So this is a brief recap. It won't be a full lecture, but it will be a brief recap of the most important material. All right, for starters, we talked about some of the assignments. So the course website has links to all the information in the course. So you should have familiarized yourself with the syllabus. Most of the information you need is in the syllabus. Okay? It's not in the syllabus because it's more detailed information about a project. It's in this web page here, which is linked from the syllabus. Some of the questions I've received are about labs. The labs are located at this link. This is a link that you can click on, and it opens up the different labs. You can choose 5 to complete for the credit. If you want to do extra credit, you can do additional labs. The lab reports, regardless as to what it says in the lab, these are the basic expectations here. So be sure to read those. There's also some notes about the labs here. Okay. The VR lab will be next week for most of the discussion sections. And then one of the 8 a.m. sections we'll have to do it the following Friday. Okay. Now, be sure for the Slack discussions that you're attaching a copy of your response in the gradebook inside iLearn. If you don't do that, then you won't get credit for it. The lecture slides are here now, and we're going to be going through the chapter 3 slides today. We'll be continuing databases on Thursday as well, so there'll be additional material on Thursday as well as a demo. The recordings, if you're listening to this, you found those already. Now the project, okay? Your group should have already met and discussed how you're going to communicate with one another. That includes who's going to be taking charge of certain aspects of the project. As I mentioned in class, action items are just another way of saying tasks. Commit date is another way of saying a deadline or a due date. And with a commit date, you pick, the person assigned to it gets to pick when they think they can reasonably accomplish the work. You should be holding each other accountable. If you're missing deadlines, then you should really evaluate whether you're being realistic when you're setting those deadlines, as well as maybe you're not keeping up with things as much as you have to. Now, the hypothetical is what your project's about. Okay? These are the business problems. I may also provide additional facts during lectures. You'll also learn about how to solve these problems throughout the course. Okay, so today, right now, I don't expect anybody to be able to go do the project without having more context from our lectures. Okay, so I mentioned things in here that may not make sense right now, and that's okay, but we will learn them throughout the course. Okay? For example, this accounting is an unsupported version of software. Well, we'll talk about enterprise systems, and I'll explain why that's a big deal, that it's not interoperable. Okay, and I'll also give some clues as to how you might solve that. So what you're going to do in your group effectively is you're going to go in and analyze these business problems, do independent research on the internet as well as what you learn in class, and then make recommendations of how you would correct these problems. Then you'll implement them. So for example, you've got a report that you have to do. This is graded individually. Everybody creates their own report, but there are 3 items in this report in the appendix that you create as part of your experiential learning down here below. Okay? Your group will create a project plan. Don't worry, we will get through that in class. I will talk how we do project planning. We will also talk about user stories. So you'll learn how to create user stories and requirements. That'll be something you do in your group when we get to that point of the class. Okay? What we will talk about today, though, is this design diagram. We'll start talking about it, and then on Thursday, you'll get some more examples. We'll go through an exercise in class, and then hopefully if you do the lab that relates to database design, you'll get some additional practice at this, okay? And this last piece here is the reflection essay. And this is just reflecting on the project as a whole. What went well, what didn't go well, what did you learn, what would you do differently in the future? This is to help you as an individual reflect on your performance on a group project, because this is not the first time, maybe it is the first time you're gonna have a group project in college, but it's not gonna be the last time. And frankly, most projects in the workplace are done as a group in some form. So it's very helpful to reflect and learn how to be more effective at working in a group, okay? The experiential learning, there's a few things that you're going to do, and it's okay. You don't need to know these things right now. That's the purpose of this class. This class is to give you an overview of information systems And as part of that, you'll learn how to use these systems. So the first thing that you're going to do here in experiential learning is you're going to create a website. I don't care what software you use to create it. I'll give you some tools and tips on what I might use. But at the end of the day, it's your choice what you want to use. If you want to go learn HTML and do it by hand, you can. But most likely, you're going to go out and use a pre-built system like WordPress or Wix or Squarespace to go out and build a website. Okay, so we'll talk about that when we get into the e-commerce section in 2 weeks. The next section is Odoo. Odoo is an enterprise system which has payroll and finance and purchasing and employee management and sales and marketing and things like that. Okay, it's an enterprise information system. You're going to go into that instance that I've set up for the class, and the details are out in iLearn, and you're going to create invoices and purchase orders, and you're going to hire employees and fire employees, and you're going to generate business reports like a balance sheet and income statement. That's very critical to be able to do. You'll learn it on Odoo, but the skills that you learn are transferable to any platform. So if you go into the workplace and they have SAP, well, you'll be able to learn SAP based on understanding how to do the task on Odoo. Okay. The next thing you're going to do is a project plan. We'll do this in class. This is going to get put into your appendix for your business report. The user stories here, I already mentioned, that's going to get put into the appendix for your report. And then the diagram, which we're going to get into this week. Okay. Then your group is also going to prepare the video presentation. These are the details you need to adhere to. I will be assigning the group numbers this week. You will get those probably later this week. You'll see them in iLearn. Okay. The letters for what you put on your name tag in your video so that we can refer to you by a letter and use that for grading, those will be assigned to you as well. Okay. So make sure that you get that information and that you retain it for later on. Read all the requirements. I would recommend each person in your group take a portion of the project, read up on it in depth, and be able to explain it to the rest of the team. Okay. And then the last aspect of the project is the project slides that go into your video. You're also going to attach those to iLearn separately so we can grade those individually, but they'll also be incorporated into your presentation. Now, the rubrics that we use for written and oral communication are here at the bottom, as I mentioned in the first class. I suggest you take a look at them because they're really the signposts for how you get an A in the course for the project. Okay? If you follow the directions for an A-level presentation or A-level paper, then you have a good chance of getting an A. Okay? All right, so let's move on to the material from today. And so this material is very difficult. So that's part of why I decided to go ahead and record a special video for this. It's tough. You're going to probably need to watch it several times to understand it. You may need to come to office hours. We will have a group office hours section on, not this Friday, but the following Friday, I'll have a group office hours. There will be space for 60 people across that hour that's in the syllabus. So 10 people per slot can fit in the room. And I also will have my normal office hours. And next week, we will also have me in some of the discussion sections. Okay. So we will start going through it. So in this unit, we're going to talk about what a database is, the components of a database, and what a DBMS is. Okay. We're also going to describe the purposes of a database and when we use them. I'll be explaining the relational databases and the ER model. By the end of the unit, you should be able to create an ER diagram if you're given data. You should be able to describe different DBMS operations, and you should be able to explain what SQL is. I don't expect you to write SQL in this course, but you should be able to understand what SQL is and what its purpose is. Okay. In these slides, there is a slide with information on SQL, and the library has a great reference available to all students. It's called Safari Books Online. It's from a publisher called O'Reilly, and all students have access to this. So if you're interested in availing yourself of that, there's a link, and if you're on campus, it should just open right up in the library. From there, you can go search for the ISBN that I published and go out and read the book online, and a lot of other SQL books out there that you can use to learn SQL. If you're not on campus, you'll need to go through the instructions the library has for the campus VPN. Okay, so let's go on with the material. So starting with, what is a database? A database is just a self-describing collection of integrated records. Okay, So a relational database is really the focus of what we're talking about right now. We'll very briefly touch on non-relational databases. They're very different. And we'll touch on those either this coming Thursday or we might get to them next week, depending on how far we get on Thursday. Okay. But a relational database is made up of a table, and that table has records or rows, as you can see in the slides here. And then those records or rows have columns, or sometimes called fields. Okay. And then each one of those fields has characters or bytes for each record. So looking at this from the perspective of, you've got a table, it has 2 rows of data. 1, 2, 3, 4, 5 is Jane Smith. 3, 4, 5, 6, 7 is John Smith. The columns represent student number. So that's the first column, 1, 2, 3, 4, 5, and 3, 4, 5, 6, 7 are student number. That's the student number column. The student name column has Jane Smith and John Smith, and then there's a final exam column, 90 and 85. Okay. From a character perspective, 1 is a character, 2 is a character, 5 is a character, A is a character. Each one of those individually is a character. So, putting it all together, what is a database? A database is a table that has columns, as you can see here. It has rows, and each one of those rows is made up of multiple characters or bytes. Now, a relational database components are, you have metadata, which describes the database, tables, and you have the relationships between these tables, as we'll get into in the following slides. So what is metadata? Well, metadata can be in any number of things, but here are some common aspects of metadata. Number 1 is a data type. When we define a database structure, we have to define for each column what type of data goes into that column. It wouldn't really do us much good if we put, for the email address, for example, if we just put numbers, which are called integers, because now we can't actually put a real email address there. All we can do are use numbers if it says integer. So if we have an email address, we use a data type of varchar, which stands for variable character, otherwise sometimes referred to as a string. Okay? That's things like John Smith, jsmith@aol.com, that sort of thing. Okay? And then integers are numbers like we have up here, the whole numbers like 5, 15, 90. There are other data types. This course isn't going to get into the different data types. If you go out and you search for database data types, you'll find them for each particular database management systems platform. Okay? So some other data types that are commonly found are dates and decimals for things like currency. You might have blobs, which are used for large files like attachments, like photos and things like that, etc. Now, another aspect of metadata are keys. And keys are how we define relationships. So, for example, this particular table, which is called advisor, has 4 fields: advisor name, email address, advisor ID, and student number. Now, you see this key field, advisor ID is called PRI. That stands for primary key. The primary key is a unique identifier in a table. And that allows us to know that if we're searching for something, we know that advisor ID is going to be unique. So we want that to be a key that we can search for in this table because it's unique. Okay? There's another type of key that we have in this table. It's called a foreign key. And in this metadata, it's shown as MUL, okay? But it's just a foreign key. What this means is we have an advisor table here, but we might also have a student table elsewhere that we don't have on our screen here. In the student table, student number is probably the primary key in the student table. But in the advisor table, it's just a foreign key. And the foreign key expresses the relationship between the advisor table and the student table. It basically just means this is a foreign key, student number. It's just a pointer to the student number column in the student table, okay? And so we utilize this foreign key as a pointer. So think of it on your computer, and you can probably see at the bottom of my computer, I have a bunch of icons for different applications. My icons are actually not installed at the bottom of my screen here. This is just a palette for me to click on my applications, which are sitting in my application folder in my computer. These are just pointers to the real location. The foreign key is just a pointer to the real location for that data. Okay. As we'll describe a little bit later, this will make more sense, hopefully, when you understand why we break things up into multiple tables. Okay. So let's look at relationships in this example. So we have 3 tables here. Okay. We have employee ID, which has the professor's information, their department information, and their course ID that they teach. Okay. We have a course table, which has the course IDs and the course names, could probably have a course description and a link to the syllabus, whatever it might be. And then we have a student table. The student table has your student ID, your name, your exam scores, quiz scores, your total score, and the course ID, okay? There have to be relationships between these 3 tables if we want to be able to pull the data from these 3 sources together. So in the employee table, we have a course ID, which is a foreign key pointing to the course ID column in the course table, okay? In the course table, course ID is the primary key. It's a unique identifier. We also have a course ID field or column in the student table. And the purpose of this is the student table, we wouldn't want to have the course name in here because what if the course name changes? We have to then go change it for every single student's record. Or what if I said BUS101 and on some people's I did BUS space 101? If I search for BUS101, I wouldn't find all the students in the class. So that's why we want to break things up into smaller tables here, so we aren't as likely to make syntax errors and things like that, okay? We have common themes of information in a single table, okay? So now we look at the data from a data model perspective. We have entities and we have relationships, okay? So on the previous slide, I was showing you tables, okay? When we want to build a data model, we look at it from an entity and a relationship perspective, okay? So entities are things that we track, okay? Attributes describe the characteristics of an entity. And then an identifier uniquely identifies an entity. Okay? So if I go here, and I'm skipping ahead just for a second to explain this a little bit more. So when we're looking at tables, which we had before, those are mapped to an entity. Okay? So a table in a design is a table. In an implemented database, it's a table. But at the model level, it's called an entity. Okay? The entity identifiers become the table key, okay, or the primary key or the foreign key. The entity attributes become the table columns when we build a database. So if we go back here to entities and our relationships and we look at entities, okay, those are the things we're going to track. So students, employees, departments, courses. The attributes are going to describe the characteristics of the entity. So student ID would be an attribute. Student number would be an attribute. Student name, final exam, total course score. Those would all be attributes of the student entity, okay? An identifier uniquely identifies an entity. So what that means is in the student table, we have a student ID number. That is a unique identifier. So that would be the identifier in our data model. Now, I'm going to show you how to do a diagram here in a second. And we went through this in class. We'll go through it again on Thursday, so don't worry if you don't quite understand it yet. We use this concept of cardinality, okay, to determine the types and relationships in a diagram, okay? So we have maximum cardinality, we have minimum cardinality. And with maximum cardinality, that's the maximum number of entities that could be involved in a relationship between 2 tables, okay? A minimum is the minimum number that are required in a relationship, okay? So let's look at this from a real life example, okay? If we have a student table or student entity, and we have an employee entity, say a professor entity to keep it simple, okay? And we have a class entity, okay? Every class must have a minimum of 1 professor, or we couldn't have a class, okay? So if we look at the minimum here, when we have a minimum of 1, we use a vertical bar, okay? So let me pull up this example here while I'm talking this through, and I think it will make a lot more sense. find my screen. There we go. Okay. So we have two entities in this diagram here. Okay. And in this diagram, let's say this one is a student. Let me make it a little bigger so that we can all see it. Okay. So let's look at this example of an ER diagram. We have a student entity. We have a professor. Let's start with a course entity. Okay. And then let's create a new one for professor. So we'll call this one professor. We'll get rid of all this stuff. Okay. So we have these entities, and now we want to build a relationship. Okay. So we've got a professor, a student, and a course. Okay. Well, there's this cool drawing feature here. We can just take a line and create it between 2 points. So we're going to go ahead and say that there's some sort of relationship, between a student and a course. We'll figure that out in just a second. Okay, so let's start with that. So at a minimum, a course must have at least one student, okay? So we've got minimum cardinality defined on here. There's one line because we must have one student in the course at least, okay? Now, what's the maximum number of students in the course? Is it one or is it many? Well, we would probably never have a course with one student. So the maximum number of students is many. So the way we depict that is what's called a crow's foot. It looks like this here, and then we've got the line. So we've got a crow's foot right here, and we've got a line. So the minimum cardinality is we must have a minimum of one student in a course, and we can have a maximum of many students in a course. Now, looking at it from the other perspective, in a course, okay, a student can have many courses, okay? So, but they must have a minimum, say to be enrolled as a student, they must have at least one course, okay? So that would be a line because they have to have a minimum of one course to be enrolled, okay? Now, let's just say that they can have many courses. Let's just assume there's no limit on courses. It doesn't really matter the number. If they can have more than one course maximum, then they would be many. So it would look like this. The relationship between these two tables, it's got 2 crow's feet, one on each side and one line on each side, okay? That's the relationship between student and courses. Now, every course is going to have a relationship with a professor, okay? Now, every course must have a minimum of one professor, okay? So we depict that with a line, okay? You can see that here. Now, in theory, and let's just make an assumption because this is how most courses are, the maximum number of professors that you can have in a course, generally speaking, is 1. So you end up with 2 lines. So it's a little bit different relationship between the course and the professor. Now, a professor, conversely, can have, must have, let's just say to be active as a professor, they have to have a minimum of 1 course, okay? What's the maximum number of courses can they have? Can they only have 1 or can they have more? Well, if they can have more than 1, then we do a crow's foot. If they can only have 1 course, then we would do a line. But since a professor can teach multiple courses, we show that as an entity here, okay? Now, we'll leave it at this example, but there's a possibility a student could have a relationship with a professor, okay? So let's just say that aside from the course, maybe a professor is advising a student. So there could be a relationship between the student and the professor directly, where a student may have many professors, but they have to have at least one professor. So we would depict that with a crow's foot and a line. And conversely, the student and professor, the professor is going to have many students, okay? But they would probably have to have at least one student. So the overall relationship between the student, the course, and the professor might look something like this, okay? And so this is showing cardinality notation for these three tables and how they have relationships with one another, okay? And notice I'm using this product called Lucidchart. There's a free Lucidchart for students. If you Google Lucidchart students free, you can find the link and you can sign up for a free account, okay? It will help you in so many of your classes. All right, so going on, now that we've got a diagram here, we can convert this to a database design. And so a database design is where we build out the tables, we create and define the keys, the foreign and the primary keys, and we define the metadata, okay? So as part of this, we go through and we normalize. We look at the data structure of these entities and we say, is this the best possible way to define the student table? Maybe the student table would be better to have student information. And then have a separate table for maybe student grades, okay? Maybe that's a better way of designing our database. Okay. So then maybe we have student grades here. And this would allow us to have grade related information. And then for a key, what we would have is we would say a primary key would be a grade ID. So that would be our primary key. And then the column name or field name would be grade ID. Oops. And then this would actually be the primary key. Okay. And so we can abbreviate that primary key with PK. Okay. Now we might have another field in here for student ID, which is a foreign key. So we could say student ID. That's a foreign key. The reason is this would probably be our primary key for the student info field would be student ID. Okay. That's a primary key. And we have a relationship of we've got to be able to identify these grades for the student to a particular student. So how do we do that? Well, we've got a unique grade ID for each grade item. We'd have a student ID that points to their student ID in the student table. Okay. We wouldn't have the data duplicated. The data would sit here. We just link it from here so we can better organize it. Right. Now, design. Tables should be constructed with a single theme or entity. Okay. So I would not want to have, say, every interaction I've ever had with a student in a single table. I wouldn't have their emails, I wouldn't have office hours, I wouldn't have their information, I wouldn't have their grades. I would break that into multiple tables, okay? So I might have student info, student grades. I might have student office hours or office visits, okay? That might be a separate table that I have. I might have another table for, say, student communications. Okay? And the reason for this is we want to minimize issues with the data later on. Okay? It's easy to fix database design before you implement it. It's very difficult once you implement it and you start actually using it in your business. So spending a lot of time up front on coming up with a good design is better than racing through it, deploying it, and then having to fix it later on. Okay? So as I mentioned before, as we go from the overall model like this to an actual design, the entity becomes a table. The entity identifier becomes a table key. So this is an entity, student info. Okay. Student ID becomes a table key, okay, for the primary key. The attributes become columns. So we might have student ID, student name, etc. Okay. And then we want to make sure as part of the design, we define the relationships and we use the foreign keys for that. Okay. So if I were to use course as an example, there would be course ID would be, oops, that would be the primary key. And we call that course ID. Okay. The data type, by the way, for something like that would probably be an integer. So we would call that an int data type. All right, so now the keys, primary is the unique identifier, and foreign references a key in another table. So for example, we would have a primary key of student ID here and a foreign key. So we would have a relationship between these two tables. Oops. Dots are very touchy. So there might be some sort of relationship between these two tables because of the foreign key there. Now, some of the types of data integrity problems that we can run into with a database is incorrect information. We could have inconsistent data. So we could have a number in one database that's different, or a great example is, say, a department. You have an accounting department, and if you don't properly scope out your tables, you could end up with a department name in a record with, say, an employee, and then go create a new department and someone puts a space in the name or names it something slightly different, makes a spelling error or something, and suddenly you end up with an employee who should be in the accounting department, but accidentally got put in the accountancy department by mistake. Okay. Another issue is data duplication. If we create the data and we put it in multiple places, so let's say I don't use keys and I just go ahead and let's get rid of this link here. Okay. Let's just say I don't do a foreign key here. Okay. It's not a key. Let's just assume that. It's just student ID. And we put it in here. Okay. And I do 1, 2, 3, and I do 1, 2, 3, 4 in this table. Now there's a problem. Okay. There's no way to link these two pieces of data together. Well, when you have these issues happen, these first three, you can have a loss of confidence in the data, and this gets a system a poor reputation. Okay. So pausing for a moment to talk about Lab 7. So Lab 7 is a beginner lab. It's very easy to do. It actually is a required assessment at another college. So it is required. It's a good assessment of your knowledge of the chapter. I really think you should do it. It's an easy lab to do, and you get the practice for your project. That being said, you can choose to do other labs instead. This is a very easy one to do, and I'll talk about it on Thursday. Okay. So, purpose of databases. Well, we do it to organize data, and we want to be able to track data with different themes. Okay. So, what exactly is a theme? So, there's a theme of student grades. There's a theme of employee contact information, okay? Department information, your personal information. And here's actually a practical example from the grocery store. The contents of the produce department are a theme, whereas the contents of the meat department are a different theme, okay? We could track them all together, and we could do that, but it would be very efficient to do that, okay? So when do we use a database? If we want to take care of multiple themes of data, then we're going to use a database. If we have a single theme of data and relatively simple expectations, we could use a spreadsheet. Now, the challenge with this is spreadsheets are not great at allowing multiple people to work on them at the same time. It can be possible, but there can be a lot of issues with that. So if you have a lot of people who are going to need to access the data and update the data, then it's probably not a great idea to use a spreadsheet. It's better off to use a database for that purpose. Okay? So how do we actually utilize databases? We use database management systems, or DBMS. These allow us to create databases, process databases, and administer them. Okay? Now, there are many types of DBMSs. For this particular portion of the chapter, we're going to talk about relational databases. And there are two types of licensing at a high level. There are many types of licenses underneath that, but there's commercial licenses like Microsoft SQL Server and Oracle, and then there are open source licenses from products like MariaDB, MySQL, PostgreSQL, etc. Okay. The difference being that commercial licenses, you purchase something from an enterprise vendor, and you get a product, and it's been tested, it's been reviewed, it's being used. But you don't have any access to the source code of the actual application. Okay? You can't make any changes to it. You're pretty much stuck with whatever the vendor provides you, which is what a lot of companies do. But there are times when maybe you don't want that type of restriction. So there's another type of license, which is called an open source license. And it is true that open source licensing means that it could be free from cost, but that doesn't necessarily mean that it's free from cost. What it actually means is freedom to the source code. You have access to the actual source code, you can verify it, you can make changes to it. If you decided you wanted to go out and take MariaDB or MySQL and make your own version of it and market it, you could. There's nothing stopping you from doing that. Okay? So a lot of companies are also using open source license databases like the ones mentioned here. For the labs, if you choose to do the advanced database labs, you would be building out MariaDB or MySQL instance either as a direct instance or using Amazon's Aurora or Amazon's RDS products. Okay, so there are a lot of different ways to do that. Now, I mentioned in the first week of class the command line and graphical interfaces for systems. A lot of database work is done through the command line. Outside of the scope of this class, but there is a very simple beginner lab. It's a game from MIT called Terminix. And I encourage you, it's a great lab to learn the command line, okay? Some of you may be working in environments where you do need to use some command line utilities to run reports for your leadership, okay? If you're going to be doing SQL reports, you're probably going to need to learn to use the command line interface sooner or later. So if you're going to do that, I encourage you to go through that lab. There's some videos you can watch as well, and they will help you with understanding how to use a command line interface. I will be showing a command line interface on Thursday as well, but that will not be something that I will test in the class. You don't need to memorize what I'm doing, but it would be good for you to get exposure and learn it on your own. That being said, there are graphical DBMS interfaces, okay? Windows users, you're very lucky because Heidi SQL is free, okay? And there's a link to it here in the slide. Mac OS users, and there's also a version for Windows as well, there's this product called Teva Plus. It's a great product, but it's not free, okay? I think the cost is around $40 or $50 for a license on it, okay? It may not be suitable for you. If you want to learn how to use a graphical interface, your best bet is probably to either use a Windows machine or if you're a Mac user, emulate Windows on your machine and run it inside of an emulated version or virtualized version of Windows. When we get to cloud, I'll talk a bit more of how you might do that. Okay. Now, in these DBMSs, you're going to do 4 basic operations. You're going to be reading data, you're going to be inserting data, you're going to be modifying data, and you're going to be deleting data. Okay. Now, how do we do that? We could use those graphical interfaces, or we could use what's called SQL, or Structured Query Language. It's an international standard. For the most part, there are some nuances between different platforms of DBMS, but for the most part, if you learn SQL, most of the commands operate the same way, no matter whether you're using SQL Server, Oracle, MySQL, MariaDB, etc. Okay, within reason, because there are some nuances between those platforms. Now, it's a critical skill to learn. It's a very valuable skill on your resume. So even if you don't have the opportunity to take the database class or UCR, I encourage you to do some self-learning of SQL. It's going to be a differentiator on your resume. It's something that if you can not only put it on your resume, but if you can actually do it, you can actually find yourself getting some really interesting jobs, helping out managers with reports, helping out the accounting department, helping out the marketing department, whatever it might be. Okay. There's a recommended quick reference book. It's not a how-to book. Okay. It's just a quick reference guide you can use if you're learning SQL that you can just kind of flip through. It's a pocket-sized guide. Okay. It's available on Safari Books Online through the library at the link on the slide. Okay. So UCR, you're going to pick the second link. So I'm just going to show you a couple of examples here on the SQL of different SQL that I've used for a particular database. And this is actually from an actual student project from one of my MIS classes, okay? So in the project, the students go out and they go and build databases for a business, okay? So that includes things like defining the different departments in the organization. So that's what this particular SQL is doing here. It's inserting into the departments table And there are two columns in the department's table. One is department ID, and the other is department name. And in that table, this code is saying the department ID is 101 and the name is finance. The department ID is 102 and the department name is human resources. Okay. It goes through and enters all those into the database, and when it's done, we can go and do the select. Select allows us to go and look at data. So we can say select everything, that's what the star means, is everything. Select everything from departments. Boom, it prints out the table with the columns and the rows of each data set, okay? That's all the data that we just inserted before. Likewise, we can go in and we can say, we want to understand what a table looks like in the database. Well, there's this command called describe. The top one's a little cut off, but describe table name. So in this case, describe employee will tell us that there's a field or a column called employee ID. And in that column, employee ID, there's a data type called integer. Okay? There's an employee last name column. It's a variable character. We can also see that the employee ID for the employee column is the primary key, and that there's a foreign key called job title ID, which actually points to the job title table and the job title ID, which is a primary key. Okay, so there's a relationship between this table and this table. Likewise, there's actually a relationship between this job titles table, there's a department ID, which is cut off, you can't really see it, that points back to the departments table up here and department ID. So there's a relationship between these three tables. All right, so here's some more examples. And this one, we have a location table, so we can do a select everything or star from location. And it shows us all the locations of our buildings for our company. Okay? We have a San Diego office and we have a Vancouver office. Okay? Now, for this one, it's a little harder to see because it's a little smaller, but it's selecting everything from the employee table. This gives us a list of all of our employees, their job title ID, and their salary. Okay? This one here, again, shows the departments. Okay? Now, if we go on, there's another thing that we can do with the database. So we can certainly get data out of it. We can certainly insert data. We can delete data. But another thing that we can do is we can grant other people access to the data, and we can create databases. Okay? So when I initially set up for this example, I created a database called HR. And you can see how in SQL I created a database called HR. If you were to go try this out, you could do the exact same thing and you would create a database called HR. Okay? Now, when you have a database, that's fine and dandy. You can access it, but nobody else can access it. So in order for other people to access it, you have to create them accounts. So just like you have your jsmith51251 at ucr.edu, you have to create an account in the database with a password for that user to log in. Okay? So these commands do sample creation of several different usernames. Okay? After we've created the user, that's fine and dandy. They exist, but they don't have any permissions to do anything. So how do they get access to do things? Well, we grant them access. So that's like giving them a key. So we're going to say, we're going to give you a key or grant you usage for this particular user to everything on this database server. Okay? And then if we want to grant access to just one database, say HR, we can do that down here. This grants only to HR, whereas this grants to every database on the system. We only granted this particular user HR access. Okay? Likewise, we can grant specific permissions. So this one here got access to the entire database. They can send data, or they can upload data, they can remove data, they can find data. This one here only can look at data. Okay? It doesn't have permissions to modify data, right? And then this command here flushes the privileges. This just basically writes all these other changes I've done. Flush privileges just writes all those changes to the database. Up until this point, I can exit and not actually have all of these take effect. Okay, so if I make a mistake, I can exit out of this, and then none of these changes are saved. Once I flush privileges, though, that's it. The database is now updated with these user accounts. Okay. Now, another thing that I can do here is after I've created a table, so in this example, it's a table called towns. I can go back later. If I forget how I created the table, I can go and say show create table towns, and it will go in and it will tell me exactly the SQL I need to do to recreate that table. So this is useful if I've created a database somewhere and I want to go create a new copy of that database. Okay? I don't have to go figure out the SQL code to make it look identical. I just go out, run this, and now I've got the SQL code that I need to go execute this on another system. And that's just another repeat of the previous example. Okay. So now there's another lab database option that you can choose. It's an advanced option, so not for the faint of heart. It is very challenging. I repeat, it's very challenging. Okay. Not to say it's not impossible. A year ago, the students in this class did this particular lab, and it was very difficult, but everybody in the class completed it. Okay, so it is possible to do, but I understand that it might be a little bit too technical for most folks in the class. But you're welcome to try it, and if it just doesn't work, you can go to do something else instead. Okay. Now, non-relational databases. There are different types of databases, as I mentioned. So non-relational databases, there's a lot of different types. So one type is called a document database. And what that means is we store everything about something in a document. So for example, a dog. Okay? A dog might be a document in the table, and that document might be, sorry, in the database. That document might be that it's brown, it has curly fur, it wags its tail a lot, it's a specific breed. There isn't multiple tables in a document database. It's all in one document for one record. Okay. So instead of having a row with some data and then a row in another table with data and a row in another table with data, in a document database, it's all in one place. I will show an example in class that I think will make sense. Okay. Now, there are other types. There are key values, meaning there is a key and then there's a value. So to give you an example of a key value database, there are two here, Memcache and Redis are examples. But let's just say a key would be animal, and then the value would be dog. So a key value would be animal equals dog, animal equals cat, okay? And you store things in a database like that. There's another type called a graph database, very far outside of the scope of this class. But if you are a CS major or you know somebody who's a CS major, these types of databases can be very valuable in computer programming, okay? And then there's another type, which again could be very valuable for certain types of application development, a column type, but they're not something that we're going to get into for this class. For this class, we're going to focus on relational and one type of document database, which is a MongoDB database, okay? Now, I will be doing a demo on Thursday of MongoDB, but there's also a lab for MongoDB. The lab option I've marked as advanced, but I have done step-by-step instructions walking you through exactly what you need to do. So in theory, you could probably do this one even if you're not technical, because there are screenshots that will help you if you get lost, okay? What I like about the MongoDB database is you can create some really cool collections and graphically display the data and sort the data graphically without having to install any special software. Okay, so it got some really cool features. It also has some features to do dashboards and reports automatically on their website. So there are a lot of cool things that you could do with it, and it doesn't require a PhD in database administration or something in order to use the product. So my students have told me that of the two, it's a lot easier to use. The challenge is it's not typically used for things like financial systems. It's not typically used for HR systems. It's usually used for things like web-based systems right now, okay? That's changing, but that's generally speaking what it's used for, okay? So that's it for this very abbreviated, well, I don't know how long it was now, but a fairly abbreviated discussion about today's material. If you have any questions, please say something in class and we'll discuss it further, okay? Thanks.